Today's video is going to be on data distributions again, but we're going to summarize our distributions. Our learning targets today are: I can determine the mode of a data set, I can determine an appropriate measure of center for the data set, and I can determine an appropriate measure of variability for the data set. So let's warm up. Let's look at this distribution on the dot plot on the right. What type of distribution is this? So go ahead and stop the video and then come back and see if you pick the right one. Okay, welcome back. So if you look at this distribution, I want you to look here. It kind of has, I'm going to draw the shape of the data. We're going to start here, and it's going to come up like this, right? So you see that all of the data is clumped to the right-hand side. Remember, we kind of talked about a dinosaur looking, here's a dinosaur here with his tail. All of the data's here, and the tail is going off to the left. So if all the data is clumped to the right, we call it a skewed left. It's the total opposite of where the data is all clumped up. All right, because the tail is pointing to the left. So we call this a skewed left distribution. So remember, in a skewed left distribution, the median would be about here, the middle value, and the mean would be somewhere over here. It would be pulled to the left. All right, so that is our skewed left distribution. Now here's just a little reminder of that mean and median are measures of center, and the interquartile range and the range are measures of variability. But you know what? We have another measure of center we could use. I think it's pretty funny. This is called the mode. The mode is the data value or values that occur most often in a data set. The mode is not the best way to measure the center of any data. All right, it is a measure of center. However, it's not a very good measure because there's so many different things that can happen in a data set. We could say that there's one mode. A data can have no modes, or a data set can have more than one mode. So the mode is just the value that occurs most often in a data set. You can determine the mode of a data set from a dot plot or stem and leaf plot because those graphs show you the exact amount of data values that are in the data set. You can't determine the mode from a histogram or a box plot, all right, because those just show you ranges. But from a stem and leaf plot or a dot plot, you can count those dots or those numbers, and you can determine what the actual values of the data set are. We're going to work on this. So let's look at the dot plot on the right. We want to find the mode. Remember, the mode is the data values that occur most often. So let's look at this. Let's look at this over here. All right. So we know that each one of these x's represents the exact data value. So we can count them all up and know exactly how many data values we have. We can also look at the tallest column of x's. And we can count how many x's there are. There's 1, 2, 3, 4, 5, 6, 7, 8, 9. So 9 values of the data set were 90. Remember when we would write out our data set, we would have an 83, 86, 86, 86, 87, 87, 87, 87, 87. So each one of these X's represents a data value. You can quickly look at the dot plot and see that the value of 90 has the most data sets or data values. So our mode would be 90 right here. So we're just looking at the longest column. So this would be 90 degrees. If you look at the dot plot, it says it's the daily high temperatures. And on the number line, we have the temperature starting at 83 going to 92. The most days that the temperature was 90 was right here. We can always look at that. It's 90. That's the frequencies. All right, so now we know the mode. What good does that do? Well, I don't know. It's not the best measure of center. We could find the mean and the median and see where that falls, but we're just learning about the mode right now. So in a normal distribution, this is what this is. Remember, it's lower at the left, it gets higher in the middle, and lower on the right. It looks like a bell. Looks like a bell curve. This is a normal distribution. In the normal distribution, the mean, the median, and the mode are often very close together. They're approximately the same. In this dot plot, the mode is in the very center of the data. So see here, this is the biggest. This has 7, has the most data values. We can count them. 1, 2, 3, 4, 5. If we were to take the mean of this data, we would add up all 25 values, divide by 25, and we would get 6 88/100ths is our mean, or our average. And if we were going to go and do our slashing method, we could find the median, right? Slash, 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 slash. We're going to keep doing this, and it's going to be, you're going to be amazed. Whoosh, 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 7. Okay, so our median is 7. So if you look at these, 7 is the mode, 6 88/100ths is the mean, and the median is 7. They're all about the same. They're not exactly the same, but they're all approximately the same. So they're all good measures of center for a normal distribution. Now let's look at a skewed distribution. We have a skewed distribution where we have everything clumped together over here. They're all clumped together over here, all this data. And it's being skewed to the left. So I want to know, what is the best measure of center for skewed data? Well, look at how the mean is also being pulled away from the median in a skewed left distribution. So when the mean is less than the median in a skewed left distribution, the mean is not a good measure of center. But the median is, the middle number is a better measure of center for skewed data. It doesn't matter if it's left or right, but you're going to use the median to describe your different distributions. Now remember, we have this handout that you can download from the IXL Classroom, And make sure you do so you have it close to you so you can look at some of the, it'll help you with your reference. When you summarize the data of a data set, that's our whole idea, is once we gather our data and we put it in organized way in one of the either a dot plot, a histogram, a box plot, or a stem and leaf plot, you can then analyze the data and you can make assumptions and predictions. But then you have to summarize it. You need to tell people about your data. So when you tell people about your data, you want to give them some information. Some of the most important information is those 5 things on the screen. You want to tell them the data value, the number of data values, what you used as a unit of measure, the shape of the distribution, and the appropriate measure of center, and the appropriate measure of spread if it actually applies. All right, we're going to concentrate on numbers 2, 3, and 4 here. We're not going to really worry about 1 and 5 right now. We will talk about measures of spread, but it won't be as important as the other 3. So as we look at this data, you have to determine some things by looking at it. It says these are the sale price in thousands of something, we don't know. And this is the frequency, how many of those we sold. All right, so let's determine the measure or measures of center that best represent this data. Remember, our measures of center are mean and median, and mode, but mode isn't that great. If it's skewed, the median is the best measure of center. If it's uniform or a normal distribution, the mean and median are both good measures of center. So the first thing I want to do is let's determine what our shape of the graph is. Is it a skewed or is it uniform or normal? Well, I like to mark my my curve because that helps me see what exactly my data looks like. Look at there. Everything's clumped on the left-hand side, and it's all being pulled to the right. So, I think we could call this a skewed, I'm just going to put an S to the right. Skewed right distribution. So if I come over here and I look at what it says, if it's skewed, then the median is the best measure of center. All right, so we're going to look at the median, and we know on a skewed right distribution, let's look here. A skewed right distribution, the mean is greater than the median. So that's kind of important. You're describing your data using the mean and median. If it's skewed to the right, then your mean is greater than the median. So we're going to go back here and we're going to say, we're going to compare the mean and the median. So the mean is to the right of the median, or it's less than. So let's say that the mean is somewhere in here and the median is somewhere in here. This would be the median and this is the mean. So we could say the mean is to the right or smaller than the median. And then we have to decide what is the best measure of center. We've already taken care of these 3, or 2. The best measure of center on skewed, anything skewed, is median. Okay, so this is going to be the median. So if I were to tell you about this data, I would say, well, in a skewed right distribution, our mean is being pulled away from the middle of all the data. So if I were to want to see how many things we sold, I would look at the median. What is the middle number of what we sold? And we would say between 10 and 19.9 thousands. Our sales were better at this interval. Okay, so this is a skewed right. And you kind of have to make your mind up. This is a lot of inferring. Compare the mean and the median. The mean is, I'm going to use the less than the median. So our median is our best measure of center. So if I were to tell my boss that we sold more things, we sold eight times as much sales. We had 8 times as much sales between 10 and 19.9 thousand than we did any other interval. So most of our sales were in this range. You know, sometimes that would come in handy if you were working in a retail establishment. Okay, let's look at another one. Let's summarize this distribution. So first of all, we have to determine whether what measure of center is the best that represents the data. Well, what kind of a distribution is it? Look, it's kind of flat. There might be an outlier down here. I think I would call this a uniform distribution because it's pretty flat. So I'm going to call it uniform. So we can pretty much say that right here in the middle, our mean and median are going to be about the same. Because we know that in a uniform distribution, if you look at your handout, look at there, mean and median are about the same right in the middle. So either one of those would be a good measure of center. So the mean and the median, the M and the M, are pretty equal, And because of our handout, we know that the best measure of center could be either one. It could either be the mean or the median, because they're the same, or approximately the same. And all that information came from that handout. There are certain rules about distributions that are for uniform or for everything. So a uniform distribution like we have here, most everything is flat. I mean, we have some that are a little bit less and a little bit more, but mostly the data is flat. Let's look at this one. Which is the best measure of center? Is it mean, median, mean and median, or neither one? So go ahead, stop the video, but think about what type of distribution is it? What's its shape? Talk about the mean and the median. Think about what that means when we look at the mean and the median. And then figure out which is the best measure of center. Okay, welcome back. So let's look at this. What type of a distribution is it? What is its shape? We want to know the shape of this distribution. I'm going to go ahead and I'm going to draw a curve. So I think all of my data is on the left-hand side. It's all clumped over here. And the tail is moving to the right. All right, so it's a skewed right distribution. It's a skewed right distribution. And we know from our handout that all skewed data, the best measure of center is the median, because that's the middle number. Look how the mean is pulled off to the right. The median is the middle value of all the data. So right here, we're going to have the same amount of data over here as we have over here. So our best measure of center for a skewed shape distribution is the median. Okay, you can always refer back to that handout. All right, your exit ticket for graph B, this graph right here. What is the best measure of center? So first figure out what the shape of your distribution is. And then look at your handout and figure out what is the best measure of center. Is it the mean only, A, B, the median only, or C, both mean and median? Remember, the mean and median is going to be right about here somewhere. Okay? So, answer your exit ticket, and then you guys go ahead and take a break. I will talk to you another day.